All right, lesson 9.2, we're going to learn some different characteristics of our quadratic functions. So let's go ahead and get started. Oops, push the wrong. Okay, so our quadratic functions, these parabolas, will all have, or could possibly have, a zero. Basically, all that a zero is it's an x value that makes the function equal to 0. And looking at a graph, it's really easy to spot the zeros of a graph because they are the same thing as the x-intercepts of the graph. And quadratic functions could have 1 0, 2 zeros, or none at all, depending on where your graph might cross the x-axis. So in this chapter, what you'll notice is sometimes we'll call them zeros of a function and sometimes we'll call them x-intercepts. Those two are pretty interchangeable and mean the same thing. So to find the zero from a graph, all you have to do is look at the graph and identify where it's crossing the x-axis. So I'm going to go ahead and zoom in on this graph right here. We can see the x-axis, just a reminder, oh there it is, it's already labeled. There's the x-axis. So where's our graph crossing the x-axis? We can see that it crosses here and it crosses here. So this parabola has 2 zeros, or 2 x-intercepts, and they are at a -2 and a +2. So our zeros are at a -2 and a +2. So pretty basic when looking at a graph for how to find zeros. These parabolas also have an axis of symmetry that came up in our last lesson. So just a little bit more specific information about it. Axis of symmetry will always pass through the vertex of your graph. Remember, the vertex is that ordered pair. It's either the highest or lowest point. Because the graphs are symmetrical, it is always halfway between the 2 zeros of the graph, or the 2 x-intercepts. And we do have a mathematical way to find it. X equals -b over 2a. So I'm going to put a star by this. This is something you do have to memorize because we're going to use it quite a bit in this chapter, and it will not be provided for you on quizzes or tests. So finding the axis of symmetry from a graph, what you might do is, I guess you could approach this a couple ways. You could find your vertex, which is down here, and we know it's going to be the vertical line that crosses through that. So here's the vertical line that crosses through. Because it's a vertical line, we know that it's going to be of the form x equals, all of our vertical lines are x equals, and that line x equals a 3. So that is our axis of symmetry. You also could look at your 2 zeros, or x-intercepts, and you know that it's going to be halfway between those, and halfway between those is 3. So x equals 3 that way as well. So you can kind of figure it out a couple different ways. All right, now from an equation, we know that we're going to do x equals -b over 2a. That's the formula that we use. Now if you remember, in standard form for quadratic functions, it's ax squared plus bx plus c. So we just have to use that b and the c. A is equal to 3 and b is equal to 6. So if we just plug those in, x equals a negative, and then we look and we're plugging in a 6 over 2 times a, which is 3. And then that's a -6 over 6, which gives us a -1. So our axis of symmetry is equal to -1. All right, last slide. The other thing that we focus on with parabolas is the vertex. That's a very important point on the graph. Like I said, it's the highest point or the lowest point. How do you find the vertex? Well, here's what the ordered pair will look like. You've got your -b over 2a. That's how you find the x value. And remember, the axis of symmetry goes right through that vertex, which is why that -b over 2a is used to find both. So you can see over here we wrote find the x value first. So you're going to do your -b over 2a. And then you plug that back into your equation to find the y. So you start with the -b over 2a, plug it back in to find the y. So let's go ahead and find the vertex of this quadratic function. Again, our a is a -1, our b is a 6, and our c is a 1. Starting with x equals -b over 2a. So both of these examples, hopefully in the other videos you'll see another one. If your b value is negative, like if this was a -6, you would put the negative in here, so you'd have a -6, and that's how your b would turn out positive. In this case, it's just a regular 6, so just negative, and then plug in your b value of 6 over 2 times a. So we have -6 over -2, which comes out to a +3. So in our vertex, we've got the x value. We know it's going to be a 3. Now we just have to plug that back into the equation for all of the x's to get the y value. So it's a negative parenthesis, plug in your 3 for x squared, plus 6 times 3 plus 1. All right, be careful when you simplify this. You do have to do your exponent first, so the 3 squared is 9, and then that negative just comes down. It ends up as a -9. Plus 6 times 3 is 18, plus the 1 on the end, and then -9 plus 18 is a +9, plus 1, which gives us our y value equal to 10. So over here we can fill in the y value is 10. And that is how you find the vertex of a parabola.